Hi guys, Mr. Collins coming at you with another maths video. Today we're going to finish off exercise 17F, looking at piecewise functions and looking at continuous and non-continuous functions. So we've covered this before, so this is a bit of revision. But when you've got a piecewise function, we need to look at on this side here, you've got your domain. So at between 0 and 1, f of x is equal to x squared, so that's the kind of graph it is, which would be a parabola. If x is equal to 1, f of x is equal to 5, and f of x is equal to 6 between 1 and 2. So to graph that, remember, all we need to do is find the endpoints. Okay, so for the first part, when x equals 0, f of x, or y, is equal to 0 squared, which is equal to 0. So the graph starts at the point 0, 0. And then when x equals 1, f of x is equal to 1 squared, which is equal to 1. So when x equals 1, and at that point we have an open circle there because it's not equal to or less than, it is just less than 1. Okay, and between that it's a parabola, so we would have a curved line connecting up the dots here. Okay, because that's the section of the parabola between 0 and 1. So when x is equal to 1, not less than 1, f of x is equal to 5. Okay, so that's at the point 1, 5. Okay, looking at this section part here. And the final part, if x is equal to is 1 between 1 and 2, so at 1 x is equal to 6, so we've got another point there which is an open circle to start off the third section of the graph, looking here. And then when x is equal to 2, y is also equal to 6. Okay, so we just do a closed circle there, and then f of x is equal to 6 is just a straight line there. Okay, so all you need to do is find each of the endpoints and then graph in between according to what type of graph it is. Okay, so we'd say this graph is discontinuous. As it's not one continuous line. Okay, and that's pretty much all you need to know about continuous and discontinuous graphs. Okay, so if it's not one continuous line, it can't be a continuous graph. So a continuous graph, an example could be something like this. So start off as a parabola, then it could go bang, even have sharp corners, doesn't matter, as at any point the line isn't broken, it's still continuous. Okay, so an example of a discontinuous graph, the one above was discontinuous, our first example there. Or you could have one that appears to be continuous but actually isn't. So for example, if you'll have a look at this graph here, but at that point there we've got the open circle. So let's say that's at x equals 2. So discontinuous as x equals 2 has no corresponding y value. Okay, so while this graph looks continuous, the fact that there is that open circle there would mean it's a discontinuous graph. And obviously, looking at this first example here, it's discontinuous as between 1 and 2, or at this point along here, there is discontinuity between each of the sections of the graph. Okay, so we'll be completing exercise 17A with this one. Thanks, guys.